All right. At this time, I'm about to start sharing live direct from our website. This is the thomsonlinear.com homepage, as you can see at the top here. Our tool is on the website, so I'll be going through this live. If you're so inclined, you can go through it live as well, follow along, or you can just watch the presentation. All of our products on our homepage are, if you scroll down, you'll see them all right here. This tool is on our shafting page, so I'll go ahead and click on that. The home page, when you click on that, is just our round rail shafting. It drops you straight into our product selector, as you can see here. There are other tabs, overview, and some literature, which lets you download or order catalogs. But for now, we'll stick to the product selector. Now, the first choice you're presented with is what kind of product you're looking for. In this case, we're going to be looking at our round shafts. But you can select other products here as well. For purposes of this demo, we'll be sticking with our 1566 high carbon steel. As of this moment, that is the only material that the special machining tool is turned on for. But if you want to use the product selector for other functions or other parts, those are available as well, just without the special machining. This product selector drops you into our page, which is a list of all products right here. It just gives you a little blurb about how our shafts are best in the industry with our high 60 case Rockwell hardness, surface finish, straightness, and incredible bearing matched tolerance. As you go down here, you'll see a few things in the shafting display. It gives you the nominal diameter, class, the minimum hardness depth, and the stock length. By default, you can see over here on the left-hand side, the filter results, it defaults to stock length shafts. So that's why you're seeing these part numbers here have the RL, which stands for random length, because that's how our stock parts are listed. You can change this to custom length over here and enter a cut to length, and you'll see this updated to be a cut to length part number with that length selected. If you click anywhere on this line, including the part number, it will take you to the product page for that shaft, either the RL, or if you entered a custom length, it'll drop you to that page as well. Because of my browser settings, this is on a different tab. Yours may look slightly different. It may open up on the same page, depends. And over here, if you scroll over, there are some shortcut buttons. This is shopping cart, which adds the currently highlighted part to your cart to order online, or takes you straight to downloading a CAD model or a PDF printout of that product page, which has all of our specifications. You can continue filtering if you were looking for a specific part, but for purposes of the special machining demo, I'm going to go ahead and go with a 20-inch long shaft. So I'll go ahead and update that here. And we'll select a 1-inch diameter. Again, this is just for purposes of the demo. The special machining configurator, as I like to call it, is available for all of these Class L shafts as we selected above. So if I go down to my 1-inch shaft and click the Add for the special machining column, it's going to pop up this warning. That warning is letting you know that the special machining we're about to start configuring will only be applied to the 1-inch shaft. This is because the available options and tolerances will change based on the shaft. So if you wanted to change to like a 3/8 diameter after you're halfway through configuring what you need, you will have to start again because the tolerances and options will change. So if we accept that alert, it's going to open up this tool that we'll be talking about for the rest of the presentation, which is our special machining product selector or configurator, depending on what you prefer. If I scroll down here, you'll see a catalog outline drawing of the shaft. All of the dimensions that we talk about today will be referenced with different placeholder letters, so the drawing is simpler. And as we populate things, they'll come in here on the bottom. As you can see, the length is represented by A, and that's the 20 inches that we entered earlier. And it talks about the diameter tolerance and the chamfer depth and angle. The tool lets you configure machining on this left end of the shaft, as you can see here. That's what's currently selected, the center, and the right end. Each of these has available options going across the top here, and we'll try out a few of these so you can see kind of what it looks like. So if I go back to this left end and say the customer wants a coaxial drilled and tapped hole, I think this is by far the most common simple value-added machining that customers are interested in. So let's go ahead and select that. This opens up a new dialog specific for configuring this. And you see it's adding two new callouts on our drawing, 81, 82, which is the tap size and the tap depth respectively. If we click on the drop down here, you'll see this is loaded with all of our standard thread taps that we have and that we often add to shafts. And this is dynamically sized based on the shaft. If you have a small one, the bigger ones will be dropped off of here. So let's go ahead and select a 540 UNC. We go over here and there's now a range of possible values that we can enter for this thread depth. Yeah, so let's go ahead and say this is going to be a 1/4 inch. Hit save. Doing so, you'll see our machining option is here for our reference, and the catalog outline drawing has been updated with this, and you'll see that 81, 82 is down here for your reference. If you say, oh, that's not right, I don't need that tap, I need something else, or if you just want to start again, you can go up here and click Edit. This brings it back to the same window with the options that we were talking about already there from last time. So we can go ahead and change that thread, say we need a metric one. You note it now flags it that this is now, because of the thread size, that this 1/4 inch is now far too small. So it's giving you a flag. If this hadn't been entered, like if that was the first one you selected, there would be no red pop-up here. But the new range is here and here. So let's go ahead and select 1/2 inch, which is how much the customer wants. We can hit save and it'll update the main drawing again. Real quick though, I do want to go back and show you some other interesting features of this tool. You will note there is a blue little icon here. That's if the customer has any questions on what we're talking about here, or if there's any additional information we think might be useful for them. In this case, it's telling you that if the shaft, the case depth might be interfering with the threads, we'll anneal the area so there'll be no conflict, but then they should expect that the end of the shaft will be annealed. So anything that's kind of like a minor, like, hey, by the way, note will be in this spot. Depending on the machining, it'll be different notes, obviously. The other thing is we do have tolerance information here. If you mouse over this, it pops up. This is just letting you know that this M8 by 1.25 thread will have the ANSI 2B thread type and that concentricity of 0.001 inch. And then if you go over here, this is the tolerance on the tap depth. You'll see it's +2 minus no pitch. That's just letting you know that this 0.5 value is a minimum thread depth. So obviously it'll probably be slightly longer threads, and further that obviously the pilot hole will be even further. So this is just letting you know that it's a minimum spec. Since I clicked on it, I didn't change anything to pull up this coaxial thread drill and tap section. So the save button is grayed out because I haven't made any changes. So I can go ahead and close this. The other interesting thing about this tool is that if I scroll back up here, you will see that these coaxial hole and external thread options are grayed out. That's because they are not compatible with the coaxial drilled and tapped hole. They have to be selected either one or the other. But we can have a coaxial drilled and tapped hole with either a single or two-step reduction or ring ruler radio hole. So let's go ahead and add a single step reduction. Now, this tool does dynamically update, so it knows that we have that drilled and tapped hole on the end there. So our minimum diameter is going to be, the range for this S1 is going to be updated based on that, and you'll see that reflected on the drawing here. I'm going to go ahead and reset this by deleting the coaxial drilled and tapped hole, and then go into the single step reduction first. You'll see the drawing does not have this featured, and the range has been opened up because we're no longer constrained by that. So the order you go through this tool, it's always going to give you the most up-to-date and accurate information as you constrain yourself by adding features. Let's go ahead and add one of these. So this is just to enter, type in whatever diameter you want. In this case, let's go with a 1/2 inch diameter reduction. Again, it is 1 inch shaft. I mentioned the symbol before. As we click on this, it's going to let us know some additional information on the reduction. And again, we have a tolerance on here. You can see that this tolerance is pretty tight, plus nothing minus 0.0005 inches. And there's a straightness on there as well. That's almost suitable for a rotary bearing, depending on what you're looking at. The reduction length, similarly, we have a range up to 2 inches. Let's go for 1.5 inches. And there'll be tolerance here as well. You'll notice that these three options, the radius, chamfer, and chamfer depth on the end of the shaft and right where the reduction meets the main shaft, respectively, are grayed out. This is because they're not configurable by the user. We just have them here to let the customer know what they should expect. And again, we have the appropriate tolerances here. We felt this was the best way to display this information to give the customer that FYI. Let's go ahead and save this. And you'll see how single step production is here if we need to edit or delete it, and the drawing has been updated accordingly. Let's go back and add a coaxial hole this time instead of a drilled and tapped one. Similar but slightly different. We just select our hole diameter. In this case, we want a number 36 hole, and let's make it 1/2 inch deep again, same as before. So both options are here. We can edit or delete them if we need to change anything, and our drawing has been updated. So at any point, when we're happy with our machining, we can click Save down here, and it's going to save all of the machining. Now we were on the product selector page. It's going to take a moment to think about it. In the background, what it's doing is it's assigning a part number. So it makes it easy so you don't get confused. It eliminates all the other options because, as the warning said initially, this configuration is only valid for this 1-inch shaft. So it still lets us go back in and change it or delete the special machining, and our part number has been updated accordingly. You also notice the list price and lead time are now displayed. And we can click on this or really anywhere on the line and go straight to the product page, same as with a cut to length part or a full length RL part. And this will give us everything we need to know about the part. So if we scroll down, the drawing we configured earlier is here for us to look at. It has a nice printout of everything. This is what we consider a 2D drawing generator. So we have our 2D drawing with manufacturing tolerances and the values selected. And when you order these parts, this is actually what our manufacturing facility uses to build the part, as we send this drawing down to the factory floor. The other thing you will notice here is there is an option to change the custom length. So I'm going to go in and do that now on a fresh configuration. So let me go back to this page, and I can click delete here. I can refresh the page. There's a couple different ways to go about it. I'm just going to hit delete. And then just to show you the other way, I'll go back to restarting my selection, and it'll reload the page fresh back to all the RL parts. So another way you can use this tool is just drop straight into special machining on the size you want. So let's say I know that I want a 3/4 inch shaft. So I can go down into the selector, filter by that, and I'm going to see our class L. You'll note there is this other filter up here, which is our recommended products, which will, for shafts, will always be our class L, because that's by far and away the one we sell the most of. If you wanted a different part, you could hit all products. And since we filtered on 3/4 inch, this is now all of the 3/4 inch options we have available. Again, you will note the special machining is only available on the class L parts. And in this case, it's grayed out for all of these other ones here. So let's go back to recommended, and let's go ahead and hit special machining. This time, instead of entering a custom length, I'm going to enter it on the product page. So if I click add, you'll note again the RL part number, letting you know this is a full bar, and that's the price and lead time for the full bar. If I click add, we're going to get a new alert. This is letting you know that you have to enter a cut to length before you can do the machining. And that's again because all of our options and tolerances are dynamic. We need to know how long the overall part is before we can start applying those filters. So in this case, let's configure a 15-inch long part. We enter that, click go, and it drops us into the same dialog. But let's say I don't want to configure this here. I can hit cancel, and you see our part has not been captured because we just entered it for the tool because I canceled. So if I click custom length, I can do the same thing, or I can just click on the random length page. Now we're on a product page. It looks similar to before, only the 2D drawing reflects just the diameter because it's a placeholder essentially. This is a full bar, so it's going to be the full length. However, we can enter a custom length here, and in fact, we can even configure special machining from this page. As before, the same warning applies, letting you know that you have to enter a custom length before this will be available. I call it unlocking. So let's go ahead and enter that 15-inch length we were talking about earlier. So now you'll notice that our product page updated, and if you're keen-eyed, you will note that even the URL updated. So we're now on the product page for a 3/4 inch class L that's cut to 15 inches long. Pricing and lead time again are updated. We can download a CAD of this. It's a pretty boring cylinder, but you can download it if you want. You can add it to cart. You can send an email asking for more information. There's links to go back to the selector, but more important for our purposes is we can now add special machining. So let's go in here and add some. In this case, let's look at something a little bit different. Let's say my user wants a custom pre-drilled hole pattern. Thomson does stock a pre-drill hole pattern that matches up with our support rails, but oftentimes customers want something custom, and this is how they could enter that. So for the center, we only have options of radial holes, and it's just, do you want it with a counterborer, or do you want it drilled and tapped, or just a hole? So let's go ahead and add a drilled and tapped hole. Now you'll note that I said a hole, and two of them are here. So there's two holes instead of just one. The tool lets you configure either a custom pre-drilled pattern that goes all the way down the length of the shaft, or just one in the center or off to the side, however you want to do it. Both of them are processed through the same dialog here. So the first things first, you can enter really any of these to start with, depending on what's critical to you. I usually go select the tap size first, but maybe we just say right off the bat, hey, I know I want 10 holes on this 15-inch shaft. So I can enter that, and it's going to start constraining everything else as we go through. If I go through here and say, hey, we want 1/4 by 20, and we want those tapped, you'll note these are blind holes, right? They're not through holes. We want these tapped to 0.4 inches deep. These two, this RDY1, is the distance from the end of the shaft to the center of the first hole. On our regular pre-drilled parts, we call this the Y dimension, hence RDY, which is round way Y1. Let's go ahead and enter a 10 inches here. Notice before I hit enter that the range of number of holes is up to 35. As soon as I say it starts 10 inches from the end, this is going to flag. Because if you want 10 holes, you can't, on a 15-inch shaft, you can't start 10 inches from one end. You need to be a little bit more specific. Now you'll note the range over here is still wide open. That's because you can kind of go through here at any order. As soon as you hit a constraint, it'll be flagged. So let's back this up to something more reasonable, like 3 inches. It likes it. It updated the range over here, and we can go to the distance between holes along the length of the shaft. Again, this range is dynamic, so this is only the values that are possible. If you start 3 inches from the end and you want 10 holes, well, then you know your distance between centers has to be this range. The minimum is actually based on the tap size, as you can see. So let's go ahead and enter 1 inch between holes and save. All right, now our drawing has been updated. We see that we have these radial drilled and tapped holes along the length of the shaft, and all of the information is listed here. If I wanted to, I could also add machining on the right end or the left end as well. If we go back to the center, you'll see that the other two hole options are grayed out because you can only have one. They're not compatible. So let's go ahead and add something different. We already have these radial holes along the length of the shaft, but we can add an extra hole that's different on this end, or the same, doesn't matter. It's just how you want to specify it. So if you want to put a hole on this end, and the range is dynamic based on that, it keeps you on the edge so that you won't conflict. So let's say this is 1 inch from the end. Now our drawing will update to show you the two different holes types. One here you can see on the end, and that's called out here, and then the ones that are going to be recurring going down the length of the shaft starting here. Doing a radial hole does gray out some options as well, again just for compatibility reasons. This hole, if you remember, or just look here at the HY1, is 1 inch from the end. So any kind of reduction in everything would have to be within that little area. So we went ahead and just grayed them out. It's not enough space. If we're happy with this, we can hit save. And again, it's going to drop us down to the product page, which is what we were on before. The last time we were on the selector, and then we clicked through to get to this page. One thing I want to stress while we're here is our website is dynamically generating part numbers that track all the machining options listed. That's how our team has it set up. So the complete part number is right here. It's long, it's not designed for humans. This is telling our web page what every option they selected is and what they inputted. So depending on the more options you select, it basically populates these X's with what you have, and this can grow to be quite long. But we're just dynamically passing this part number to our website, and our website is configuring this page with the drawing and everything on the fly. You can imagine that with all those options on there, it'd be something like 30 million web pages, and we don't want to pre-generate all of those. So it's all done dynamically. The only reason I stress that as being important is for when it comes to ordering these. You will note there is a button to add this to cart right here. That is for end users. It gives them this part pricing and lead time for the part they've configured, passes it straight to our web store, and they can purchase it. For distributors, this is our one-piece list price. So all of our distributors will get discounts that will make this much lower based on both quantity, because that setup charge will be split among more shafts, and because you get a distributor discount. So all you need your customer to do is configure what they want on here, or maybe you configure it for them, and they'll see our list price. Then you can take this part number and give it to us, and we can quote you whatever quantity with your discount, and you'll be good to go to place an order against that. The web store doesn't currently allow distributor discounts and quantity discounts on these parts. So I do recommend that you place your order via your typical ordering processes. If you want to avoid having to highlight and copy paste all these part numbers, if you scroll down, there is a Get Quote tab, which lets you fill out your information, and this will drop you straight into our customer management system with the part number. So you don't have to copy anything. You can just have the customer configure it for you, maybe on your computer, or just send you the part number. There is a send email button, which if you click it, will pop up an email that's been pre-filled out with the part number. So again, no copy paste. You can just have them click that button and send it to you. You can click this. It's going to open up this page, because again, it's just passing the part number to our website. And then you can just tell us, hey, give me a quote on this. They want 5 pieces. That covers if the customer is configuring this themselves. But I did mention earlier that you can configure something for them. A lot of times we have customers come in with just a verbal request or maybe just a rough sketch. And I like to use this tool to configure it so we have a nice print for them to go off of. It helps with avoiding errors because it gives them something to maybe sign off on, or it just helps avoid confusion and gives them a nice picture. And again, we use this for manufacturing at our factory, so we'll probably do it on the back end anyway. So one option is a customer tells you just verbally that they want a 2-inch shaft and they want, a reduction on it. So you can come to our website. You can either just go filter to 2 inches, or you can just scroll down and grab it, go to the product page, and okay, they want 35 inches long and they want a reduction. So I know I can go in the Thomson's website, click on the single step reduction for the side they want, and start configuring. If they said, hey, I just want a 1-inch reduction that's 2 inches long, very fast, we're done. It's only one value added part. Hit save. It's going to go ahead and change our URL because we're dynamically been sent to this page that has all the information we need from the part number. You can tell the customer that's what the list price and lead time is from Thomson, and get a quote with your discount by clicking on get a quote, or just copy and paste the part number and email it to us, or however you like to get your quotes. One other thing I did mention was that we manufacture from this drawing. So this is a tool primarily that makes these 2D prints. So if you want to configure a part on here and then do the machining yourself, or elsewhere like a local machine house, that's also valid. Thomson thinks this tool is valuable enough that we want to make it free for anyone to use on our website. And if you start coming to our website and configuring things, the hope is that you'll buy more Thomson product, of course. But we think it's a valuable enough tool to share without putting a price tag on just using the tool. Obviously, we hope that you buy the parts from us, either our cut-to-length shafts that you machine, or a random length you can stock and machine, or obviously the machine parts themselves. But we know there are multiple use cases and didn't want to restrict it by gatekeeping a price on the configuration tool itself. All right, I did want to go through one more machining option before we go, which is something we haven't touched, which is a ring groove. The left end machining is just telling you want to put either the ring groove or whatever on this side. That's self-explanatory. Right end, same thing. Groove, reduction, hole on this side. One thing I did want to mention while we're here is that the center machining always assumes starting from the left end. What I mean by that is that Y dimension we were talking about earlier will always be drawn from the left end. It's just kind of a restriction of the tool that maybe you should be aware of. If you're going through it and your customer has maybe an old print, or you're just translating a print they gave you into this tool to get pricing, You might have to flip it in your mind or something to make it work based on that. So let's go on the right end this time and add that ring groove. Again, as with everything else, we're going to let you know, hey, what the radius is. As you can see, is grayed out, but we'll let you know. We can say we want 0.1 inch groove. It is reduced to a diameter of 1.5, which is the minimum. Remember, this is on a 2-inch diameter shaft. Distance from edge, again, we're on the right end this time. So the Y2 is going to be from the right end to the groove. We have a longer shaft, and we can do basically up to the halfway point, essentially, is what this range is locking you to. This is going to be just 1 inch from the edge, though. Go ahead and hit save. You can see that here. You can go nuts. If you add more options, you can do that. It's going to dynamically gray out things and give you tolerances based on what you've already entered. And just like before, when you're happy, you just hit save, and it's going to give you the full part number, and it's passed you to that product page and dynamically loaded everything, including the drawing. All right, so that concludes the tour of our special machining product selector.